Hi, Algebra 2. Today we're going to discuss Chapter 11.4, which is Experimental Design. So when we talk about describing an experiment, one thing that we want to talk about is a controlled experiment. And I know you've all heard these words before, but a controlled experiment is when there are two groups who are going to be studied under identical conditions except for one variable. So in terms of like a drug study, one group would be testing out the new drug and the other group would be testing out the placebo. It's really important for them to not know which group they're in. Your control group is going to be the group that's subject to no treatment. Okay, so in the case of a drug trial, that would be the placebo. And then your treatment group is subject to that treatment. So whatever you are testing, that group would receive that. Looking at some extra practice, the directions want us to determine whether the study is a randomized comparative experiment, and then if it is, to describe the treatment group, and the control group. If it's not, we need to explain why it's not and discuss whether the conclusions drawn from the study are going to be valid. So, example 1, we have baby DVDs improve language ability. To test whether baby DVDs that highlight words and introduce music and art can improve language ability, parents with babies 0 to 24 months were given the choice of whether to let their babies watch the DVDs. 50 babies who watched the DVDs were observed for a year, as well as 50 other babies who did not watch the DVDs. At the end of the year, the babies who watched the DVDs scored higher in language development tests. So our first question is this a randomized comparative experiment? And the answer to that would be it's not. It's not randomized because they were given the choice. So then if we look at whether the conclusions drawn can be valid, well, it would make sense that the babies who watch the DVD would have a higher score in language, but is that the only thing that was different? So maybe the babies who watched the DVD, maybe their parents are very much more into developmental skills, and they also read to their kids more. So we don't know. The thing that makes you be able to draw a valid conclusion is that this is the only thing that's different, but there's so much more out there that we don't know is different that we cannot contribute their higher score in language just from these DVDs. All right, looking at number 2, we have a new drug improves blood glucose control. So in a clinical trial, 100 type 1 diabetic patients volunteered to take a new drug. 50% of the patients received the drug and the other 50% received a placebo. After 1 year, the patients who received the drug had better blood glucose control, while the placebo group experienced no significant changes. Do we think this is a randomized comparative experiment? Yes, because these were just assigned randomly to the two groups. So yes, this is randomized. So then the directions say describe the treatment. So the treatment was this new drug that they're using. The treatment group is 50 people who were taking that drug. And the control group was those that received the placebo. 50 who were on that drug, and then the placebo. All right, up next we're going to talk about randomized in experiments and observational studies. So we really want them to be random. So in an experiment, we get random. Individuals are assigned at random to either the treatment group or the control group. So that's how we get random in an experiment. In an observational study, when possible, random samples can be selected for the groups being studied. So if you take a random sample from who was being studied, then that randomizes it. So good experiments and observational studies are designed to compare data from two or more groups and to show relationship between variables. Remember though that we just want that like one variable that we're testing there. A well-designed experiment can determine a cause and effect relationship. So going back to the babies and the DVDs, right? Did this DVD cause the babies to have a higher language score? And so a true, well-designed experiment can determine that. So just to reiterate that a little bit, a rigorous, randomized, comparative experiment by eliminating sources of variation other than the controlled variable, so that goes back to that one variable, can make valid cause and effect conclusions possible. An observational study can identify correlation between two variables, but not causality. So correlation, as one thing increases, the other thing increases, but maybe the first thing did not cause the second thing, and then that happens a lot. Variables other than what is being measured may affect the results. So last we're going to look at examples 3 and 4. Explain whether the research topic is best investigated through an experiment or an observational study, and then describe an experiment or observational study. So the first thing we want to look at is a criminologist wants to know whether social factors are the cause of criminal behavior. So would you rather set up an experiment for that or do an observational study? Probably an observational study, because if you take them out of their environment, they might not behave the same way. So if we do an observational study, and then how would you set that up? Instead of writing it out, I'm going to talk through it. So one thing you could do is find different backgrounds, almost like if we want these social factors, so we're going to find groups from different places, so maybe high crime places if we're trying to figure out if it causes criminal behavior. So we have high crime places, and then you would also need not high crime places, and you're going to pick a group and you're just going to observe them on a regular basis. All right, and the last one here, a pharmaceutical company wants to know whether new medication for heart disease has a side effect on individuals. Well, you would probably want to do an experiment on that one. And one way you could do that is you could randomly choose the same number of individuals who have such medical conditions and place them into two groups. So we have individuals with heart disease. We're going to put them in two groups randomly, and then one group takes the new medication and the other group maybe stays on the old medication that they're probably already taking if they have known heart disease. And then you're going to record any side effects that they have. All right, that's what I have for you today. Not much, but hope you can get through it. Let me know if you have questions. Have a good day.